In this unit, we're going to focus on solving equations. In this lesson, we're going to look at equations that are set up as proportions.
All right, hi everybody. So in this lesson, we're going to look at what we might call type 7 equations. Okay, and really what we're talking about here are these are equations where we've got a rational on both sides. Okay, so we've got a rational expression equal to a rational expression. So basically A over B equal to C over D. And there's nothing else going on there. That's all it is. It's just fraction equal to fraction here. And we call that a proportion. Okay, so like it says right there, a proportion is two equivalent fraction statements. Okay, and that's what we're looking at right now. So one recommended strategy for dealing with this is cross multiplication. So you've probably seen that before. But it only works. We can't emphasize that word enough here. It only works if it's fraction equal to a fraction. If there's anything added extra, then that needs to be dealt with before you could ever do something else. You would have to add those terms together to get fraction equal to fraction here. But this is what it looks like. Let's take a quick look at the example here. So I've got a fraction on the left side. I've got a fraction on the right hand side. So what we're going to do here is we're going to multiply the denominator of the left-hand side with the numerator on the right-hand side. And then we're going to multiply the numerator on the left-hand side with the denominator on the right. And that's what we're seeing in this step right here. And those should be equal. Now, if you're not sure exactly why that should be equal, let's just take a quick look at this. Let's say you've got, well, okay, we know that 2/4 is the same as 5/10 because they're both 1/2, right? So we already know that they're equal to each other. Now watch what happens when we multiply 4 by 5, okay? And look what happens when we multiply 2 by 10. So notice in this case we're going to get 20 and 20. They are going to be the same. Okay? They're going to be the same. So there you go. So now what we do is once we've got it, once we've multiplied down, now that we're in this step right here, we're going to distribute through. We're going to simplify both sides. So we're going to get the 3x plus 12, and over on the right-hand side, we're going to get 6x minus 6. Then we're going to bring the terms with x to one side. So in this case here, you can probably see that what they did was they subtracted, and I'll just erase that for right now. They subtracted the 6x from both sides. And then they subtracted the 12 from both sides. And we got negative 3x is equal to negative 18. And then when we divide both sides by negative 3, we get 6. And there's our solution. And so that's what's going to happen here. So it's just that cross multiplication step right away here that changes this to a different type of equation that we've already spent some time working on. So now let's take a look at some problems. Okay, so here we go. So for this problem right here, again, we've got fraction equal to fraction, so we're going to cross multiply. So it will be the denominator of the right side multiplied by the numerator of the left, and that will equal the denominator of the left multiplied by the numerator of the right. Okay, and again, we can do that because these are equivalent fractions here, and then I'll distribute the 2 here on the left, so that'll become 4x plus 6 is equal to 5x minus 30. And we typically like moving the parts with the variable over to the other side here. And actually, I should, you know what, I'm gonna be consistent with what I set up before here. Once we start getting to this point right here, I wanted to make sure that people saw the different steps here. So I'm gonna do this in red. And whoops, and so that's gonna give us is it gonna be negative x, and then I'm gonna subtract 6 from both sides. So it's gonna be negative x is gonna equal negative 36. And then we're going to divide by the negative 1, and we get x is equal to positive 36. Okay? And that's all there is to it. Actually, this really doesn't add a lot of complexity to these problems to have it fraction equal to fraction. Although a lot of times it looks like it is because there's a general tendency to not really like working with fractions here. So for this one right here, I'm going to multiply the denominator of the right by the numerator on the left. That will be the denominator on the left by the numerator on the right. So we're going to get 8 is equal to 8k minus 72. And then I'm going to subtract. And I know that's going to leave me. I know that there are easier ways to do this. I totally get that. But I also know that there's going to be a lot of people out there that just won't like to do it any other way here. And so we're going to add that 8 to both sides. So this is going to be negative 8k is going to equal, oops, sorry, not add. My mistake. We're not going to add that 8. Oops. We are going to subtract that 8 from both sides. And so it's going to get us negative 80 over there. And then we're going to divide by negative 8. And then we'll get k is equal to positive 10. And then this one right here, the denominator on the right multiplied by the numerator on the left will be the denominator on the left, which is this nice little binomial here, multiplied by the numerator. And then we distribute. Okay. And now we're going to bring the terms over. So negative 9n, and then we're going to add 24, and we're going to get, okay, negative 5n is going to equal 114. And then I'm going to divide by negative 5 on both sides to get n is equal to, negative 114 over 5. Because it doesn't really matter whether that negative is drawn or placed in the numerator or the denominator or even out front of the fraction. But it typically looks better either out front or up in the numerator. Okay, so now what you might want to do at this point here is take a couple moments here, try the next two, okay? And then maybe pause the video, come back, and take a look and see how you did here. Okay, but I'm just going to move ahead here. So this will be 7 times x plus 9 will equal 6 multiplied by x plus 8. I will distribute coefficient. And then I'm going to subtract 6x from both sides. I kind of like how that's looking. I'm going to subtract 63 from both sides here. And I'm going to get x. Love that, because that basically means I don't need to do the next step that I've been doing, the blue step, if you will, up in the previous questions there. And then I put that together, negative 48 minus 63, that's going to be negative 15. So there we go. And then this one over here, okay, notice what happens when I've got on the right-hand side here. It's just a number. So what I'm going to do is I'm going to put that over 1, just for simplicity's sake here. And so now this is going to be 4 times 1, which is just going to be 4, is equal to 5 times x. Now, I'm going to do something here that I haven't done in previous questions here. I'm just going to do this. I'm just going to change the order here. Because it's an equality, it doesn't really matter what side, like how you write it here. Like a equal b is the same as b is equal to a here. I can flip those. It's not even so much doing operations. I can just, if they're equal to each other, then it doesn't matter what side of the equal sign you write them on. They're equal, okay? So now once I do this, I can divide both sides by 5, and I will get here that x is equal to 4/5. Okay, and so there you go. So that little bit of extra math that's added by making it a proportion or fraction equal to fraction is very easily kind of dealt with just by that cross multiplication.